Okay, we're back at the lab table. I had to break this video back up into two parts just because of the time limits. And I'm going to show you what has happened to the KHP. Let me get my safety glasses on. The crystalline material, the potassium hydrogen phthalate, has dissolved in the beaker of water. I'm going to transfer it to a Erlenmeyer flask, and I have this one labeled as KHP also. And we'll just pour it in. And then we'll begin to do the standardization of the sodium hydroxide. So over in my burette, one on the left, this is the one that has the base. That's the one I want to put my solution into. And in order to do this, what I'm going to do is I'm going to do a stirring method with my right hand. That's my dominant hand. And then I'm going to adjust the valve here to let more or less sodium hydroxide in based on the change in the solution that I have here. Now I'm going to put a color indicator in, and I'm going to use phenolphthalein for that. It's one of the indicators we looked at the other day. It is a powder, a white powder, that we begin to work with when we mix it and make it into a solution. So I put a bunch of drops in. I'll swirl that to make sure it's in there. And incidentally, while I was picking up the phenolphthalein in the storeroom, I ran across another bottle of it, and I'm going to bring this up a little closer. And this one has white residue all around it. In fact, some of the white residue is coming out the sides of the bottle. This is something we sometimes find happens over the summertime. And sometimes just over a period of time in the lab, things change. Well, apparently what's happened with this bottle, it's so old, I do know that it is old, that it has developed cracks in it. And so the solution inside has been slowly coming out and leaving phenolphthalein to crystallize on the outside in the air. And that's typical of sometimes what happens with old bottles. So all I'll do with this is I'll transfer the liquid, get rid of the bottle, put the solution into a new bottle. But it's an interesting little side attraction. So let's put that aside. Here's my solution now. We have the phenolphthalein in. Let's start to add the base. Let me bring this up a little higher. So I'm going to swirl with my right hand, add the base with my left. And as soon as I put base in here, I'm noticing every once in a while there's a little shift in color for the solution inside the Erlenmeyer flask. And we're gradually adding the base to this. If I let this sit in one spot, you might be able to determine there's a color developing in the solution. Let me turn that off a little bit. I want to get this to be a color that's permanent. And right now, as it fades away, that tells me that we have not finished the testing of the standard yet. When we get it to the point where it stays a color, then we'll know that we've reached the volume that we need. Nope, still fading. But we're getting close. Okay, we have a nice pink color in that, and that tells me that the solution has now reached the stage where I can figure out what the concentration of the sodium hydroxide is. And what I'll do that is I'll read off on the burette what the volume would be, and I'm going to put my finger at the level of the meniscus, and I'm reading straight across to the meniscus, and it says 28 milliliters. So I'll write that down, and that'll be a piece of my data. Now I'm going to get set for the acid-base titration, so I'm going to stop the video here for just a little bit. So we're back up here the front of the room with the board, and I want to show you what some of the math looks like for this standardizing of the sodium hydroxide solution. I'm going to start off by showing you that I used 0.51 grams of the KHP, potassium hydrogen phthalate. I want to convert that to moles, so I put 1 mole KHP over its molecular weight, and that's on the bottle. That's a little bit of a time saving because it's nice to know what it is just real quick and rather than calculating it. But if we were to calculate it, we would find it's 204.2 grams per 1 mole. Now, when I do math here, this is a simple step. I find grams of KHP, top and bottom. I'll cancel those out. And then when I do the math, when I multiply, when I divide these, I will get the number of moles of KHP. So I'm going to leave that for you to calculate, moles of KHP, and put that in your notes. And then the next thing I want to do a quick calculation on is the volume that we used. So here's how many milliliters we used. 28 milliliters of our base solution, NaOH. I want to convert that into liters, so I'll put 1 liter on top, 1,000 milliliters on the bottom. I'll divide, and that's simply a matter of shifting the decimal place, and I will get 0.028 liters of sodium hydroxide. That's how much sodium hydroxide I needed to react with the KHP. Up at the top of the board, we saw before that the amount of potassium hydrogen phthalate and sodium hydroxide that we used is in a 1-to-1 mole ratio. So the number of moles of KHP that I eventually get as my answer here over a liter will tell me what the molarity of the solution of sodium hydroxide will be. And let me just move this a little bit, and I'll put this over in the corner of the board here for you. Let's move this over a little closer. So here's my calculation. Take the moles of KHP and put that over the number of liters we had, 0.028 liters sodium hydroxide. This is equivalent to the moles of KHP, but we can also now just change it into sodium hydroxide because they're in a 1-to-1 mole ratio. So we'll put sodium hydroxide here. And when you do the division here, you will get the answer as moles per liter for sodium hydroxide, which is the capital M symbol that we saw before for molarity. Now, I'll stop the video, go back, and do the titration with the acid for you. In the transition between the board and our lab setup, I want to show you the next final phase where we do the titration of the sodium hydroxide and the hydrochloric acid. I'm going to show you what the chemical reaction looks like, and I'll leave this up here for a couple seconds for you to copy. The process is called a titration. I'm starting with NaOH, that's my base. I'm going to add to it some hydrochloric acid. When it reacts in a 1-to-1 mole ratio, and we will get a salt, NaCl, which happens to be table salt, and water. These will be our products. And typically in a inorganic neutralization, when you combine an acid and a base, you get some kind of a salt, and then you get water. So here's the chemical reaction for our process here. And I'm going to start off by taking an empty Erlenmeyer flask. I'm going to put into it some acid, and then I'll begin to put in, I'll put my indicator in, then I'll begin to put my base in. I'll compare the volumes at that point, and then knowing the volumes, we'll eventually be able to figure out the molarity of the acid compared to the molarity of the base. So let me move this back a little bit. I'm going to add 25 milliliters of acid to my flask. And in a lot of titrations, what you can do is set the acid up and the base up as separate burettes, and this enables you to manipulate the volumes in such a way that if you happen to overshoot a endpoint where the color changes, you can go back, add a little bit more of the other reagent, and then more slowly add the opposite agent until the color changes fast and not changing, and not too intense either. So let's add our 25 milliliters of acid to the flask. The burette is draining. I'm going to bring the burette's volume down to 25, which is roughly where my finger is. So I'm watching the meniscus. Let's get ready to turn this off. We're down to 22, 23, 24, 25. There's 25 milliliters of acid in my Erlenmeyer flask. Let's add some phenolphthalein to it. Just a couple of drops, that's all you need. I think we got enough in there. We'll swirl to mix it. And now we'll start to add our base. And again, I'm going to do this in such a way that I'm using my right hand and then control the addition of the base with my left. So if you were doing this titration, you kind of get used to doing it a certain way, and as you do that, you get more acquainted with the motor skills, and it works a little smoother. Now normally, if you were doing this in the lab, we would do this 3 times, and we would get our volume of base compared to the volume of acid, and we would record that. We'd do a second trial, and then a third trial, and then eventually what you would do would be to take those trials and average them to get a average value, and that would be used in your calculation for the molarity of your acid. So we're starting to get a little lingering of the pink color. Let me slow down on the addition of the base here. We want to try to achieve the same pink color that we had before. And we're almost there. Just a tiny bit more. And I want this color to last for about, we're just going to add a little tiny bit in addition to that. And now we have a color that's not completely fading on us. Oh, it is. Let's add just a little bit more. A quick twist of the valve enables me to add additional base. And now when I compare my 2 colors here, I can see that I've achieved pretty much the same color. So I now know that we've achieved the neutralization here. And I'm going to write onto the piece of paper here how many milliliters I used of each solution, and that we will eventually use in our calculation for the volumes and then eventually the molarity. Final step, I have to do a little bit of cleanup. So here's the burette that I had the acid in. I've already dumped out the base from the sodium hydroxide side. And here's a quick way to do this. Take your burette, you got the valve, you can control that. Turn the burette upside down over your reagent beaker. Open the valve, the air comes in from the bottom, and the acid drains out. The final step that I'll use is to rinse water through those burettes to make sure that they're clean. And then for your calculations, I'll just hold this up for you now. The reaction that took place involved 25.4 milliliters of base and 25 milliliters of acid. And what you now can do is take the volume of your sodium hydroxide, multiply that by its molarity, which you have to calculate from what we did on a board up there, and then compare that to the volume of the acid and the molarity of the acid that you used. And I'll put this information on the Moodle website for you, so you'll be able to follow the calculations. That's it. Titration done.